Hello, hello, hello. So ever since I have finished the photogrammetry course, people have been asking me to showcase the workflow of me actually working on a project and, doing the whole thing from start to finish. So this is going to be a video about that. I will not be showing you how I took the pictures of this particular house. I'll talk about the house in just a second, but I will be explaining, what happens after you have taken the pictures, so the software that I use, and so on. So this is going to be like a bonus material for the photogrammetry course. This house is a Japanese Ryoanji house based in Kyoto, an old machiya, an abandoned building that we have purchased and we're currently renovating. And we have purchased it last summer, and this summer the renovation has began, right? So these pictures are from actually from this summer, right? 1,323 of them. By the way, if you're interested to actually see the whole project and the documentation of the whole project and so on, please check out the second channel. I have video series about this renovation project there. I'll leave a link to that in the video description below. The idea of this is that every time a new phase of construction happens, I 3D scan the whole thing and I have an archival 3D model to which I can go back and see what changes have been made and what crooked areas have been fixed, right? With that being said, these photos are in raw format, right? There's a lot of them, and I need to have all of them basically have as much information as they can. So the first thing that I always do is Control A, select everything. This is Photoshop, by the way. You just drag and drop them into Photoshop. Camera Raw plugin opens up, and then I go to Light, and I basically kill all of the highlights. You can see, this is the original. Please take a look at this area in particular. Oh, that's blurry. Okay, this photo will need to go away. Let's go for something a little bit better. Yeah, that's much better. So for example, these tiles, right? They are completely overblown, over white, over bright, sorry. But if I kill the highlights of them, see how much information comes back? Let me show that again. This is how it was before. This is with the highlights killed. I can push this further, these highlights further down by pushing down the whites right here. Usually I use minus 30, minus 25. Then same thing applies to the shadows, right? If I increase the shadows, see how much detail I get from the shadows? And if I increase the blacks, I also get some detail, deep detail in the shadows. Usually that detail is not that useful because it's too noisy, but in some cases it really does make a difference, right? So this is before, this is after. You want images to be as flat as possible. In addition to that, I also go to color and, not color. We don't mess with color. I go to effects, and for the clarity, I just increase the clarity by either 5 or 10. In this case, I'll do 10. And that's kind of it. It already recognized what kind of camera this is. It's Fujifilm X-T4. I assume it understands the lens. Nope, it doesn't, but it automatically removes chromatic aberration, and I am happy with that. Actually, I'm kind of curious. Let's see if I actually go to optics, use profile corrections, and I go to, we were using Fujifilm, Fujifilm, Fujinon. Okay, that's only a 50mm lens that that are available to fix. So that's why it can't recognize. I was using a 16mm lens. It is what it is. That's fine. Okay, so basically these corrections, this highlight correction, the shadow correction, the whites, the blacks, and the clarity have to be applied to every single image so that we bring in as much information from the highlights as possible, as much information from the shadows as possible. Then once that is done, I just click on save, and I go basically to the JPEG format. JPEG format is technically you should use TIFF, but that is too heavy in terms of the file size. the file sizes are way too big. So I can't afford to have 1,300 pictures in TIFF format. So I use JPEG. And quality, I set it to 10, 11. In this case, I'll set it to 10. I don't need the quality to be that high. 12 is overkill. You don't need 12 unless you're doing some real professional work that needs, but at that point you need light more than the quality of images. Anyway, once that is done, I just hit save and it starts saving in the predetermined folder, right? This is gonna take a long time. I'm going to stop the recording and we're going to look at the images once it's done. There we go. Now it's done. So this took like 20 minutes or so, maybe 15. And now we have all of the JPEG images and I'll just open up the first one and we'll just go through them. Not all of them, of course, but I'm basically now going through every single image that I have and I'm trying to find any images that seem blurry, that have motion blur or simply are unusable. Another 10 minutes passed. I deleted 100 images or so. Now we're down to 1,266 images in total. And all of these, oh, there we go. So this one right here, on purpose, I left it in. And that is because I wanted to show you an edge case. In this case, this is blurry. This is out of focus, right? But in my experience, even though this image is out of focus, it has enough information in the blur for it to act as an anchor to two other images that are in focus, right? So it's basically like a map for two other images to kind of find each other as a pair, right? It's weird how it works, but this is an edge case for me, and this is something that I just approve having in the data set just as a helping hand. If it was even more blurry than it is right here, I would discard it because it would mess things up more than it would help. Hopefully that makes sense. With that being done, I have my 1,200 blah, blah, blah images. And now it's time to actually run the reality scan. So ever since I did the course, the reality capture has become reality scan, exactly the same program, exactly the same menu, exactly the same performance. Performance a little bit better. And everything is basically the same. So the course is not out of date. The way of how I work in reality scan is I just select the whole damn thing, drag and drop it in, right, into the inputs. So all of my images live here. And then all I need to do is just go to alignment and just align them. Click on align images.
Well, after 22 miles, 6 hours, and 3/4 of a bottle of whiskey, not to mention those 3 pints of beer, with bicycles somehow still in one piece. Is it?
We have a result. And the result is pretty good. So here I see that 1,213 out of 1,266 cameras were used. And we definitely have something. We have a house. All right, so let's see. And I look through cameras because I'm very, very curious about the back right here, the balcony, right? If we can actually get some information from the balcony. So here, for example, I can see the neighbor's wall, and I can anchor, for example, to this bolt or to this bolt, and see if there are any images in the small components that correspond to those two bolts, that have those two bolts in them. So I'll begin with this F3. Zoom, zoom, zoom. No, that's our neighbors. We're looking down on our neighbor's porch almost. And I can almost see the bolts right there. Let's take a look. If I were to, okay, bottom, we have a chance. Bottom bolt right there. So that's my 0.0. And then bottom bolt right there, that's 0.0. And bottom bolt right there. There we go. And this is complaining like crazy. I'll double check if I have the correct bolt set up. Right in the middle of it, please. That's fine. That's fine. And that's fine. Is it? It's fine. Okay, so here I have three cameras that are looking at point zero. That's fine. And now in my big component, component one, I want to also kind of anchor to that particular bolt. So I choose point zero here. I press F3 and I try to get as close as possible. Oop, that was not good. Control Z, F3 again. I will try to get as close as possible to that bolt. And then I will just simply drag. Where are we? There we go. I'll drag the point zero to the bottom middle of that bolt. Let me just double check. Yeah, that's the correct one. Middle would be there. Middle would be there. And middle there. Now it found more options for me, which is great. We kind of want more options. Okay, with that done, I think we're good to go in trying this again. Again, I will not be using merge components. Instead, I will be using align images for now. So now the next step is going to be aligning the whole, what's the 3D model, the whole point cloud, aligning it properly. It seems like it did a pretty good job at finding what's horizontal and what's not. Well, somewhat horizontal. It's an old house, okay? So the floor is a little bit crooked, but it did a pretty good job figuring out that that's the floor and that should be horizontal. But you know, the alignment and the XY axis is all the way off. We're gonna be working on that, but I'll be doing that tomorrow because now it's quite late. These alignments take time. For you, it's gonna be just a second. For me, I'll see you tomorrow. Good morning. Okay, so we continue with this, and the first thing that I see with fresh new eyes is the misalignment, and I guess that's what I was talking about in the evening. So the bounding box, this is the reconstruction region in which the mesh will be made, is kind of a off angle from the building itself and the street. So the way of how I fix it is I go to, I believe it's tools, or I think I just click on it. Yeah, okay. I just click on the box, right? And I rotate it. If you don't see the reconstruction region, you can always go to Scene 3D tools and set, I believe it sets region on grid, something like that. And then it's going to show up. Either way, now I'm just going to position it properly, something like that. It doesn't need to be perfect, but you kind of want it to be properly aligned. And I will be grabbing just a tiny bit of the neighbor. I don't really care about all of this data. And the reason for that is because I don't really want, the top is actually fine, maybe a little bit higher. I actually don't really want to have too much, um, too big of a mesh, because then my materials will need to be also very, very large, or rather a lot of them. So something like that. And of course, bring it back like that. And I don't really care about the trees on the other side of the river, of the street. There's also like a canal here, but I don't really care about, or actually, screw it. Let's get them in here. All right, something like this. And once this is done, I also would like to set ground plane. Click on the little arrow right next to it. Set ground by reconstruction region. Bam. Now it's basically aligning the building using the ground plane, or sorry, using the reconstruction region on XY axis. Now we're ready to make a mesh. So to do that, I just go to mesh model and I just create a normal detail mesh model from the point cloud that I have within the bounding box that I have put down. This takes quite a bit of time. So yeah, I'll see you when it's done. All right, there we go. So right now what we see here is a dense point cloud, and that's because the resolution of the mesh is too high. Actually, if I were to look at this, 233 million polygons. There's no way that my graphics card can actually show the whole mesh, but there's a trick. So if I go to a scene 3D view, right around here, we have the clipping box tool that I can use. Let's go in here. That I can, where is it? That I can use to create a box around the, like any space. And then technically, this is weird. Why is it not building the, oh yeah, we need to actually choose sweet render mode. Or, well, we don't have texture, so solid would also work. But basically with the box, we would be previewing only, the geometry that's inside of the box. Then you will notice that the rotation of the camera is a little bit wonky. To make the camera rotate around any object, any point, you just double click in space, and then the camera rotates around that point in space. So here what we have, actually, let me build this a little bit higher. Have no idea what this is. Oh no, I do. This is actually the inner yard, the front yard. Let's bring it up like that. This is like a small rose tree that we have in the front yard and our wall. Like everything's in order, and I can see a cable running through here that was captured. Like everything seems to be fine. And that's the only reason why I would use a clipping box. Other than that, just looking at the point cloud and seeing if the points match up, that is also sufficient. Let's build the UV unwrap. And the way you do it, or the way I do it, if I go to mesh model, unwrap, here I would choose, first of all, how many texture tiles do I want for this whole geometry to be unwrapped, right? With a certain texture, well, texture of the model. In here, I would say well, first of all, I always choose maximal texture count because then I can actually put down how many 8K textures do I want. And for a building such as this, I would go between 10 and 16. In this case, I'm using 12. And that's about it. You don't really need to do anything else. You just calculate the unwrap. There we go. It's done. Only took like a few minutes to do. Now, where's that clipping box again? To actually preview the density of the UV unwrap, I actually need to see the mesh. And I'm just gonna click, click, click. Only here, only this area. And that's basically the resolution of the texture that I can expect. And honestly, this is sufficient. I will never be using this for anything other than just archival purposes. So that resolution, you can see, how blurry the pixels, well, not the pixels, the pattern is. That is fine. And don't worry about the seams here. They will not be there because well, I think they won't. No, they won't be there because once we project the actual texture, it's gonna clean it up. Okay, so with that done, let's clear clipping box, and all we need to do, mesh model, texture. This is gonna be a heavy one. This is gonna take a long time. Time to pause the video again. All right, there we go. So it's been a few hours, but now we have a colored point cloud. Well, it's actually a textured mesh that we're seeing here, but the resolution is still too large for us to actually see it. Now I can see that it's breaking apart, perhaps, maybe not. Hard to really tell. We'll see. We'll see if it's breaking apart. Either way. Now what we're going to be doing is actually checking the quality of the texture by simply, you guessed it, where is it? Clipping box. There we go. And I'm just gonna make one, like that. And technically, if we give it a second, it should load in. Okay, so this is a loaded in colored mesh. This is a loaded in low resolution texture, and this is loaded in high resolution texture. And it seems like everything's working. Okay, let's move. What do we do with you? Let's take this and move it right here. Just check out the quality. So the quality is not that great. I mean, of course, we can get a much higher resolution mesh or much higher resolution texture from this. But the question is, do we really need it? Because this is sufficient for us to understand, what's where even the nails are present. So that's fine. How many? 10. 10 textures have been created. That is good enough. Good enough. Okay, let's clear the clipping box. Looks nice. Looks real nice. And then before I export, of course, I still need to, make this reasonably sized. Right now, 233 million polygons is way too much. So I'm going to go to mesh model and I am going to, is it mesh model? No, it's Scene 3D Tools Simplify tool. And I'll drop it down to actually 9 million. So absolute tolerance or not tolerance type for simplifying is absolute, and target triangle count is 9 million. So 9 million polygons instead of 200, blah, 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 33 million. I think that's going to be fine. We could actually drop it down even further. I'll go for 8 million. 9 million still seems to be a little bit on the high side. Okay, what's next? Minimal edge length, that's whatever. Density, equalization, we have it enabled. Color reprojection, normal reprojection. So I'm actually going to also enable color reprojection because I haven't been using this before, but it seems like the texture is going to be reprojected on top of the simplified mesh. And let's check the parameters. Same as source for unwrap. That's excellent. Yeah, let's simplify it. There it is. Okay. So we now have a 8 million polygon mesh that we can at least preview. I have turned off the cameras and also I had to do a few shenanigans with recalculation. Don't worry about it. It's not important. What's important is the backside is quite messed up, while the front side is okay. And the reason why the backside is messed up is because the only angles from which I could take the photos were from the second floor balcony, right? So there were no photos taken from me just being outside, from the neighbors' houses or anything like that. With that being said, this is sufficient. This is sufficient because for an interior, that's pretty good. I think that's pretty good. And if I look at this, there's not a lot of misalignments. You can see some mesh misalignments. I think I saw one. Where was it? Just bear with me. Yeah, there it is, right? These bumps happen usually when like two photos are misaligned, but that's not too big of a deal in this case. That's fine. Right. So the quality of the scan has turned out to be pretty good, and I'm especially happy with the stairs. 1 second, let me just try my best to navigate to the stairs. Double click there, zoom in. Come on, there we go. So the stairs have turned out to be great, right? This is important because this is the only thing that really connects the first floor and the second floor, and the alignment worked out. So that's great. That's great. That's great news. Okay, besides that, now what we need to do is clean this up, import it into Rhino, and that's going to be it for the video. So cleaning this up, the way of how I do it is basically I do it in 3 parts. Part number 1 is getting rid of all of the floaters, as I call them. So stuff like this, meshes that are separate from the rest of the geometry, just these floating bits and pieces, and that don't give any additional information to our main mesh. The way of how we can clean this up is by simply going to Scene 3D tools. That's going to be advanced selection tool right there. And then here I just simply choose the, where is it? Select the largest connected component. Select it. Bam, this gets selected. And you can see that all of the small bits and pieces are not selected. So what I do then is I just invert it. right? So a bunch of small stuff is selected. And yes, we will lose like a railing uh, broken mesh thing. That's fine. That's not a big deal, right? And then I just simply choose filter selection. Give it some time. And we have successfully removed 100,000 polygons just like that, right? After this is done, then the next step is to actually turn that off. The next step is just to check if the mesh integrity is correct. And we do that again through, actually through mesh model tab, check integrity, check topology, these two, right? So first I'll check the integrity, model is okay, we're happy with that. Check topology, that usually takes a little bit longer. Model is okay. So this is ready to be exported now. In total, we have, again, actually only six 8K textures for the color and six 8K textures for the normal. That's a little bit on the lower side, but that's fine. That's fine. In future videos, I will be showcasing this in virtual reality on the second channel. So keep an eye out for that. To export this particular model, I will just go to export dense mesh model. And I'm just going to call it, let's just make a new folder, exports, and Ryoji scan. There we go, like that. I prefer to use OBJs. Save. Then in terms of the settings, I don't really change much. Honestly, I don't change anything. Let me see if I'm lying to you. No, all of these are default transformations. Like no, yeah, nothing has changed. So I just hit OK. Now, as it's exporting, I'll turn on Rhino so that we can check how it imports. Give it a second. Actually, this is interesting. I unpaused the video just to show you. You can actually see the textures being created in real time. And the reason why I'm so stingy about the textures, about how many textures we use, because we could use, 100 8K textures and then we would get like photorealistic, like you could go this far to the wall and still see detail in there, no pixelation. But the thing is that each of these guys is 73 megabytes, right? Each of the normal map textures are 85 megabytes. So when we look at, was it six? 1 second. Yeah, when we look at six 8K textures of the model, in total we have 12 because we have normal maps as well as the bitmaps. And in total, this is 1 gigabyte of data. And then the mesh itself is another gigabyte. So this whole thing, this whole export, 8 million polygon mesh with its textures is 2 gigabytes of data, almost 2 gigabytes of data. It's a lot. It's really, really a lot. Okay, let's check it out in Rhino. Bam, bam, bam. Drag and drop. And I'll just choose to open it. And there's one thing that I didn't do when I was scanning this in Japan, and I didn't put down a ruler. Usually, you do either two stickers, and you know that between those two stickers you have exactly 2 meters or 1 meter, and then you scale accordingly. In this case, I didn't put anything down, but that's fine because I already have precise CAD model of this house, which means that fitting the mesh and scaling it properly to fit with the CAD model is not going to be a big deal. So once this is imported, let me just select the whole thing, and it's not gonna be lightweight. You can see that every part in here, it says 135 parts in total. I don't think it's gonna be 135. Rather, it's going to separate the mesh according to the textures, right? So if I were to Control A, 6 meshes are selected, right? So it's actually only 6 parts. You can't really join the meshes, but you can group them together. If you join them, the textures will all mess up. Okay, and then I just rotate this 90 degrees. You can do that transformation during the export phase. I don't really care. I think I rotated it wrong. Let's first look at it in the rendered view, because rendered view shows you the, what's the word? It shows you the actual textures. And now you can actually see how much slower Rhino is compared to reality scan, because of the, just optimization. Reality scan is optimized to show high density textures and high density meshes, while Rhino is primarily a modeling software. But eventually it does the trick. Let's select our meshes, I should say. Rotate them 90 degrees. Not the fastest, but suitable. And then, in Rhino, I'm much more comfortable with orienting the camera and working with the camera. Just looking through. I didn't take enough pictures of the ceiling here. That's my bad. But this is still sufficient to understand, how the ceiling is, how it goes. And then no pictures were taken of the top of here, so there's no information there. Plenty of information about the neighbors. That's great. Understanding how close the neighbors are and understanding the viewing angles that the neighbors will have. The balcony. The tricky bit of the back roof, I managed to actually pull the detail back in with a few anchoring points. How are they called? 1 second. Control points. With a few control points here in the back. Point 11 being there, point 7 being there. That was sufficient to bring in the back of the roof. The front of this roof is much higher in quality, and that's because I was standing here. Actually, I was standing right here, and I didn't take pictures of my feet. But basically, as I was kind of walking around, I took a bunch of pictures of this. Besides that, second floor, I'm happy with the result. First floor, the facade is great. Yeah, the facade has great results here. Of course, nope, didn't happen. The reflection got us, and also I didn't take enough pictures of that. That's fine. And once we enter, yeah, that's good. Now we can actually see, the whole situation that we have here. Nasty. That's going to be a lot of work to make that nice. And then we have this. The old bathtub has been removed. Yeah, okay. This is becoming the other video. And again, if you want to see videos about this Rayonji house renovation project, then check out the second channel. Link in the video description below. If you want to see this 3D model, or if you want to play around with this 3D model, I'll put it down for Patreon supporters of the channel. Also, link in the video description below. I'll see you in the next one. Later.